Right, this is a typical me type of thing that I would do. So we'll say it's Wendy, who's going off to the beach. And I'm going off to the beach I leave at my house at 10 o'clock. And I walk for 6 minutes and then realise I've forgotten something. Forgotten my wallet, can't buy an ice cream. Takes me 2 minutes to go through all my pockets, check all my stuff. So instead of making it the whole way to the beach, which is here, so you have to think of this 0 meters as being my home. And the 800 meters, which is where I'm trying to get, is the beach. Okay? So it takes me a couple of minutes to realise I don't have them. So at 10:08, I go back to run back to my house. And I run twice as fast as I was walking in the start, because I'm in a hurry now. So you can see that this slope is not as steep as my homeward slope. I'm then at home for 3 minutes finding my wallet, and now I want to rush to the beach at double the speed I had originally. And I think that the original speed was, it took me 6 minutes. So here I ran 400 meters in 6 minutes. Let's make sure. And what I do know is I went with double speed. So if I had a speed then of 400 meters in 6 minutes the first time around, and second time around I had double the speed. That means that in 6 minutes I'd have been able to run twice as far. So my speed next time around, so my first speed to the beach was 400 meters in 6 minutes. My second speed to the beach would be I'd be able to go 800 meters in 6 minutes. And that's really all you need for this question. So it's going to take me 6 minutes to go 800 meters. I know that I was 3 minutes, the graph gave you this, 2 minutes at home looking for my keys. Then I ran back to the beach and it gave you that you got back to your house at 10:12. Then it took me 3 minutes to find my wallet, and now I need 6 more minutes to actually get to the beach. So 1, 2, 3, 4, 5, 6. That would be here at 10:20. And I'd be able to go at 10:20, I would have gone 800 meters. So here is my 800 meters line. And I will have gone, so filling in your time diagram, your distance time diagram is very important to be able to do. I'm starting here after I finished looking for my keys, my wallet, and I found them. And then I run back to the beach. So this speed time diagram tells you a little story. You can see, if you think of this point as being my home, it took me 6 minutes to go half the distance to the beach. Start looking for my wallet. Oh dear, I've forgotten it. Takes me 2 minutes. I'm not walking anywhere. I'm not going anywhere. I'm standing in the same spot. I've not moved from my home or the beach. I'm just waiting here. So time is ticking on, but I'm not getting any closer towards the beach or any closer towards my home. So whenever it's horizontal like this, it means you're staying in the same spot. You're not moving either direction. Then I go back to my home. So my curve now is, my slope now is a negative gradient. I'm going backwards. So I can see what's happening here. I'm going to the beach. I'm stopping before I get to the beach. Time's ticking on, I'm going nowhere. Now I'm going back to my home. Now I'm running and rummaging around in all my drawers and coats and everything else at my home. Time's ticking on, but I'm going nowhere, looking to find my wallet, and then finally find it. Start here at 10:15 running down towards the beach because I've got to meet friends. Okay, so this is how we would represent a distance time diagram. Important, we label our axis here. This is the distance from my house to the beach in meters, label with units, whereas this is time in minutes. Okay, the time in minutes starting at 10 a.m. So it's not just minutes, it's actually a time on the clock. Okay, how could I have worked this out using speed time diagrams then? Well, we know that we often use the Swedish one, SVT, where S is sträcka. Usually I use DVT because D stands for distance. Distance, velocity is the same as speed, and time. And whenever you make these, you put a line like that, which means you're dividing line between these terms here, and a time sign between the two terms in the corner. So this is how this should always look. So we know that first time around we had a distance of 400 meters and we had a time of 6 minutes. So let's use this to work out the one that we don't know. The one that we don't know is velocity. Velocity is, we use our formula here, velocity, cover the one we want, what do we get? Well, here we can see that the D is divided by the T, so we write it like that. Velocity is distance over time. Okay, we now know that the distance is 400 meters and the time is 6 minutes. Make sure you don't use M and M. You've got to differentiate between meters that you can use M for, minutes you have to use MIN, otherwise it's the same as meters. Okay, let's leave it like that for now. And let's do second time around. So this was to the beach. And I'm showing you this method in case they give you more complicated numbers next time. This one was actually quite easy. But if they'd given you more complicated, and maybe the camera doesn't actually, does it? Can you see that now? That side of the board as well? Okay, so to the beach. Okay, time 1, take 1. And then to the beach, take 2. What do I know? Well, I know that I've got twice the speed. So I know that instead of the speed being 400 over 6, I know that my new speed is twice as fast. Let's take 400 over 6. Gives us a speed of 66.6 recurring meters per minute. So if this one is going to be twice as fast, we actually just double that number because the speed she's running twice as fast. It's 133.3 recurring meters for every minute. That's going to be my speed second time around. I know the distance to the beach is now 800 meters because I'm going to make it all the way to the beach. Okay? What I'm wondering here is, what is my time? Well, in order to get the time, I cover the one I want with my hand and I get its distance over velocity. D over V. The distance is 800 meters. The speed or velocity is 133.3 recurring. And hey presto, when I put those numbers into my calculator, I get a time of 6 minutes. So I know that it's going to take me 6 minutes from when I start running to when I actually get to the beach. So this one is using your math skills and your formula, your speed time formula, to demonstrate what you actually already knew. This way is useful if the numbers are a little bit more complicated. Okay? So that's how we use speed time diagrams.